Okay, in this class I'm going to look at a question that came up in 2003 on the higher level paper involving three particles. Particle of mass 3 rests on a smooth horizontal table, no friction, and is attached by two light inelastic strings. Masses are negligible. To particles of mass 6 and 1 which hang over smooth, light, no friction, masses negligible pulleys at opposite edges of the table. Systems released from rest. Calculate the acceleration of the system in terms of g. So I'm going to draw my force diagrams for each of these particles. The 1 kilo, the 3 kilo, and the 6 kilo. And you'll see that we're just going to have a kind of an extra variable in here from before, but we solve it in essentially the same way. There's no huge difference. The 1 kilogram mass has the force on the mass by gravity, which is called its weight. That's just 1g. And pulling up is the force on the mass by this string. Now this string here is different to this string, so we can't say there's one tension, so we'll call that maybe tension 1. The 3 kilogram mass is a bit more complicated. It has a force acting down on it, gravitational force, or the weight. The normal reaction acting up, which is going to be, you can see automatically, it's going to be 3g. It's going to have that tension pulling to the left is going to be the same as that tension pulling that up. So the force on that particle by that string is called the tension. We'll call that tension 1. And then there's a different tension pulling here to the right, so we call that tension 2. And then the 6 kilogram particle, again, much more simple. The only forces acting on are the force on the particle by gravity, which is called its weight, which is always mass times little g, and then the tension. And that tension up there, you can see, will be the same as that tension there. That's T sub 2. Okay, and that's kind of, that's kind of all the hard work done, really. The rest is just a bit of algebra from here on in. F net equals ma. That's our force equation. From the first one, again, maybe think about what's going to happen based on the diagram. What I think is that that's going to go up. I think that's going to go right. I think that's going to go down just because of the masses given. So I'm going to call this an up positive. I'm going to call this a right positive. I'm going to call this a down positive. We don't have to worry about friction at all because everything is smooth. So from the first force diagram here, the up force, positive force T1, negative force T is G, so the net force T1 subtract G, that's going to be equal to MA, which is just going to 1 times A. There's my first equation. My second equation, let's call that equation 1. My second equation from the 3 kilogram force diagram. And again, I'm just worrying about left and right. The up and down forces, they're just balancing each other out. There's no friction. I don't have to worry about that. I think this is going right. So the positive force is T2, negative force T1. So net force T2 minus T1. And that's equal to MA. Well, that's going to be 3 times A. And then finally, my third equation here is going to be it's a down positive system. 6g is positive force, T2 negative force. So 6g subtract T2 is equal to MA, which is 6A. So there's our 3 equations. We want to find the common acceleration of the system. The acceleration of the system in terms of g. So we're trying to find A. So what I'm trying to do is kind of eliminate T1 and T2. So what I'm going to do, the way I would solve this is from equation 1, I would solve for T1. T1 is going to be equal to A plus G. From equation 3, I would solve for T2. Make T2 the subject of the equation. T2 will be 6g minus 6a. And what I would do then is I would use these substitutions. Plug this value for T1 in here, and I would plug this value for T2 in here. Then I've got one equation that involves just A as the only variable. Very simple to solve. So therefore, from equation 2, substituting everything in, T2, which we're saying is 6g minus 6a, subtract T1, well that's subtracting all of A and G, so subtracting A and subtracting G, that's equal to 3A. Solving, really straightforward now. Make A the subject of the equation. So on the left hand side, 6g subtract g, that's 5g. Adding 6a, adding a on both sides, so adding 7a on both sides, we get 10a. So the acceleration of this system is going to be 5g divided by 10, or 1/2 of g, or g over 2 if you want, meters per second squared. So really nice, simple question, came up in a higher level paper in 2003. 3 particles, so we're getting 3 equations. And again, in your maths course, you've looked at solving equations with 3 variables. Okay?